Okay, so today's topic is some applications of trigonometry. Though we have covered the introduction part of it, this is somewhat similar, and what I feel is this is more practical, okay? Because when we study trigonometry and we are studying tan theta, cos theta, so somehow the person, somehow the students, I mean, they want to relate any of the persons who is dealing with the chapter, they want to relate it to the practical scenarios, okay? And relating it to practical scenario is very essential to our learning, okay? So in trigonometry we have gone through like tan theta, sin theta, cos theta, okay, and some of the derivations of it, some of the like trigonometric ratios, some identities which are very essential. But these two chapters are kind of a club chapters, okay? So once you study the first chapter, introduction of the trigonometry, then the second chapter you should always study the second chapter. You should not leave any time, okay? Because these are the practical applications of trigonometry in your day-to-day life. And until unless you use it over there, studying the first part, it's not very meaningful, okay? So if we are like we have studied that, we have gone through the ratios, identities, we have like solved some problems, some numericals, but what is the feel inside that, okay? The feel is the applications of trigonometry. So how we can how is it related, we will see it today, okay? We'll try to explore few things and let us see. Suppose there is a scenario, there is a lighthouse somewhere in Europe, suppose, okay? ऐसा एक lighthouse है, ठीक है? इसमें यहाँ पे there is a bulb, suppose, and this is C, ठीक है? I have suppose a boat over here, or let me have a bigger boat. Okay, so suppose if somebody wants to, this is a scenario, you should take it as a scenario only. Suppose this is the lighthouse, okay? Generally lighthouse, there is a light at the top of it, so whatever boats are coming, okay, so they can show that light, okay, in the sea, and they can show the way also many a times. So if in case suppose you want to calculate the height of the tower, of this tower, okay, and when the height of the tower is till this light, suppose, okay, so what do you need to know? One thing is you somehow calculate the height, okay, since the tower is there, you know the height. But many a times, suppose you do not know the height and you do not want to measure it also, then what can you do? Can you use trigonometry somehow? Consider the waters are still in the sea, the waters are very still, and the boat is like slowly coming towards the, okay, and if suppose you have like made the boat stable for some time and you have an instrument, you have a nice instrument on your boat through which you can measure the angle, okay, and this instrument has a nice feature, or it has a laser light, suppose, okay, this has a laser light and you can just show the laser light towards the tower, and suppose it is the night time, evening time. Okay, when you are showing the laser, so there is an angle and the laser will go like into the sky like this. Okay, ऐसे भी हो सकती है. So next time it has got a rotating angle, this device. Okay, next time it goes like this, it has lowered it down, and again now it is like this one. Okay, so now he can see no more, light is not there in the sky at the back, so light is obstructed. And what is that light? Light is basically it is a laser light. Okay, so new kind of an instrument he has developed, and he has got that laser light. So what does he do? What does that instrument do? So it has got a circular arc, and whenever he throws the light, so that arc will tell you the angle from the horizontal. For that I will use another color for the horizontal. Suppose this is the horizontal line. Okay, ऐसे. So in that case it will show the light. Definitely practically we can have an instrument like this. Okay, what do you think about it? उसमें laser light है सोचो. Okay, there's a laser light, और वो जहाँ भी wherever you will throw, it will hit the wall. Maybe it will reflect, but we are not that much interested right now into that. Only thing it should obstruct. So first of all, he's trying to just fit at he's trying to get the top point of the lighthouse. Let me write as a lighthouse. Lighthouse. Okay, एक lighthouse है. तो उसमें उसने whenever he like throw the light into the air, so it was going into the air, and you can see the laser light, है ना? It goes like till very long, so you can easily see that it has not hit the top of the lighthouse. Now he is lowering the device, because the device has a suppose device is something of that sort, इस तरह से है ना? And there is a laser angle. Okay, and it shows the angle also, ये वाला थीटा. ठीक है, इस तरह का एक डिवाइस मान लो ऐसा. This is laser, and this is angle. ठीक है, and this is base. Getting it? So he tried it, and at the top of it the light is getting obstructed, so he can see that okay, it is making some angle. Now this device will show that angle. Okay, because this device is on the boat and you have this device. Okay, so angle, suppose this angle is theta. Okay, theta would be some in the practical scenarios, because the device will exactly show okay kitna hai. So you can have a mechanical device also, you can have electronic device also, depends, but definitely the angle can be seen. Okay, so if suppose this angle comes out to be 60 degree. Okay, theta is equal to 60 degree, कुछ भी आ सकता है. Okay, it can come anything, because we do not know the height and we are just trying to measure it. Okay, whatever angle will come, we'll take that, but in our scenario we're taking angle as 60. Getting it? So now we do not know the height h. Okay, and suppose this is almost in line with in the base of the lighthouse. Okay, so we will get an kind of an approximate height. Okay, some meters plus minus, but generally if that is like lying on the boat itself and the top on the bottom, and height is also measured from the ground, so just consider them at the same level. Okay, maybe a little difference could be there, but you'll get some kind of an approximate. Okay, plus minus a few meters. So now you have got like angle is there because it is your boat and you are not measuring the lighthouse, which is very tall, and you are measuring the angle. You can measure the angle and you can see the laser also. Suppose it is evening time, you can clearly see the laser is getting obstructed. Now what? And suppose, and next thing, you should know this distance, base B. Okay. Getting it? ये B. This is base B. That is height H, and this is angle theta. Now, if we have got these three things, okay, base B you can always measure, okay, because that is the horizontal part. Other thing is, now you can apply this principle to any of the buildings. Okay, suppose a minar is there, so you can apply the same. Okay, this is a different scenario, but if you are on the ground, you can easily measure the ground distance. Okay, and you stay wherever you want, because if you are very close to that minar or lighthouse, then your device will show the angle which will be greater than 60 or some, it will be the greater angle. Okay, and you can measure the base you can measure, base you have to measure. Okay, one thing you should know, then you can easily calculate the height. How we can calculate that height? Let us see. Suppose now our triangle will become like this. This is B, this is B, this is height H, this is theta. Okay, A, B, C. Getting it? Yes, sir. Now which trigonometric identity will trigonometric ratio will you use in this case? Should I use sine theta, cos theta, tan theta? Which ratio should I use? Please tell. Getting the question? We are using the trigonometry over here. Okay, we want to use it, and that is how it is used. Scenarios could be like, there could be a number of scenarios in different like different locations they might be. Okay, some engineering it might be there, maybe you are going to another planet, there you are trying to figure out few things, whatever. Okay, so should I use tan theta? What do you think? Tan theta is perpendicular upon base. Okay, am I correct? Tan theta perpendicular upon base. If I write it as H divided by B. Okay, now tan theta is equal to H divided by B. Tan theta. Okay, H is equal to B tan theta. Now if you know B, if you can measure B somehow, if you are on the ground, you can easily measure. Okay, if you can measure B and tan theta, suppose theta is, if theta is equal to 60, okay, and B is known, then h can be found. Okay, h can be calculated. Calculate. Getting it? H can be calculated. So this is how you can use it. Now we'll take another example. Okay, let us take one more example. Suppose there is a house, multi-story building is there. Okay, suppose it. And you are standing outside as an engineer, you have come here. Okay, and you just you are like an officer of the government, and you want to see that whether the people have are the people like what are the limits. Okay, there are some municipality limits to the buildings, uh, and you are just checking that. First of all, you're doing a survey and you're seeing the what is the, because they are before even talking to them, you are just taking their, okay, you want to calculate the height by yourself, and then you will talk to them and see them and see their papers or what, and what is the height, what is the building you have constructed, have you taken the permission, what are the permissible limits in this locality. Okay, such kind of things happen. And now here you are coming as a municipality officer, okay, development officer. Now you got the same device, you put your device, and now you're like throwing the laser as a, okay, the laser is going above, it is not obstructed, so you again throwing the laser, again going up. Okay, now this time it hits like this. Just calibrate it over there and just try to see the angle. Okay, try to see the angle, kitna hai ye, theta. Okay, what is this distance is b, again this height is h, same thing. Okay, you've got a nice device, now you're seeing that. So approximately you'll get, okay, again now suppose the theta has come to be suppose 75. Okay, your device is showing a 75. So you're just hit and trial, you're saying like once you're rotating your device a little above, you can see the laser in the sky. Oh, you're like putting it little down, so the laser is getting obstructed, so you can see that this is the kind of upper limit. That is how you can do. Okay, so now again you will use tan theta is equal to height upon base. Okay, getting it? Theta is 75. Now h is equal to, same thing over here also, h is equal to b into tan theta. Okay, इस तरीके से b you can calculate easily because you are standing outside the building. You will just measure wherever you want, you can put your device, and wherever you are putting your device, just measure the distance of the building from that, which is easy, which is on the ground. So you can have your inch tape, etc., measuring tape, whatever. Okay, and you can, maybe you are having one or two people along with you, and they will measure it for you. B can be measured. Theta, your device is there, the angle is given. Now you can easily calculate the height. So this is some kind of a practical scenario. Okay, and now you have gone, like you have calculated the height, and now you're seeing, okay, height has come out to be this. Oh, the permissible limits are very low. Permissible limits are only two, till 2 floors, and he has constructed third floor. Now you can talk to him. Okay, so such kind of scenarios could be there. Okay, so in this case, when the angle is above, this is called, when the angle is above, इस तरीके से above है angle, it is like going above your eyesight. So these are called angle of elevation. Angle of elevation. Always remember this, angle of elevation. Why? Because you are like looking up. Okay, so it is like kind of an elevation to you. That is why these are called angle of elevations. Getting it? Okay. So this is how we should think. Whatever we are reading, maybe math. Okay, math in itself is math is a kind of a supporting science. Okay, so it helps you to calculate many things. So this is kind some and for practical purposes you should have some device. Okay, some calibrated meter, because whenever we are like reading these, and suppose the other day you're going for some job or you're going to some government department, then definitely the engineers will have the real device. Okay, because they have to do the work, the final work, for either like for the certification process or whether permissible limits are there. So they should have some kind of a device to do these for the application of these trigonometry. Getting it? So
Yes,
these
sir.
are some scenarios, है ना, इस तरीके से. So now if you see any person, if he's doing such a kind of a work, so you can easily see. तो अब इसी में suppose you are going little closer to the building, ऐसा भी हो सकता है. Okay, suppose the same building is there. Same building is there, and now your engineer is like very near. बोल रहा है कि base मुझे check नहीं करना ज़्यादा. So I am like going near, and he is like calibrated, put his device over there. Say, ठीक है? ये डिवाइस आ गई है उसका. ओके, ये एंगल है, ऐसे डाला उसने, ये एंगल उसका निकल आया ये वाला. ओके, विच इज लाइक थीटा मे बी 2, थीटा 2 है ये. ओके, suppose this is theta 1, I'm taking this is theta 1, theta 1, theta 1. Okay, so this is theta 2. So in this case the b has reduced. Okay, this is b new. Height is the same because we have to measure the height. So now what he is doing, tan of theta 2, even you can have a measure, you can have a calibrated thing for this also, tan theta. Okay, perpendicular upon b new. ठीक है, h is equal to tan theta 2 into b new. Okay, same thing. Now theta 2 is, you can your device is showing the theta 2, and b new is, you can measure that because you are even closer. Definitely theta 2 will be greater than theta 1. Okay, थोड़ा सा बड़ा ही हो जाएगा वो, and you can find out. Here also this theta 2 is angle of elevation. Yes, it is an angle of elevation. Getting it? We'll take another scenario. Suppose there is a building, okay, and there is a balcony to it. I say, okay, some ball is lying over there. Suppose football is there. Okay, football. And now sister is there. Sister is looking at the ball, okay, from the balcony. So now if we see, this is the horizontal. If we draw a horizontal line, okay, so from our sides we are like looking down. Previously we were looking up, so now we are looking down. So if we are saying this angle, what is this angle? Angle is theta only. Okay, ऐसे समझ लो. दिस इज योर लाइन ऑफ साइट, इस तरीके से दिख रही है आपको। ओके, सो दिस थीटा इज कॉल्ड एज एंगल ऑफ, जो नीचे की तरफ है हॉरिजॉन्टल से, दिस इज हॉरिजॉन्टल, हॉरिजॉन्टल। ओके, theta is called as angle of depression. Okay, why angle of depression? Because the point is below, I mean the line of sight, that thing is below the horizontal. Previously it was above the horizontal. Getting it? This is, excuse me, this is angle of depression. And this angle will be equal to this angle always by the, do you know this principle? By the principle of the parallel lines. Do you know this? Okay, so parallel lines, and if there is a line cutting these parallel lines, so these angles will be equal and opposite. The top angle, that will be equal to this. Okay, so if suppose base B is known, okay, we can easily calculate the height h. Getting it? Same thing. Okay, getting this scenario? Okay, so this is also one scenario. In this case, the theta is equal to the lower theta between the line of sight and the horizontal. Horizontal, in the horizontal means ground. This ground line, ये वाली जो line है. Okay, so these two thetas will be the same because they both are ground, and the above horizontal line, they are the parallel lines. So if any line is cutting and if it is making some angle with the top horizontal, the angle would be the same with the ground horizontal also. Getting it? ठीक है? And you can think a number of ways of doing it. Okay, just to get the feel of it. Suppose some building is there, सभी हो सकता है, और इसमें कोई फ्लैग है, मान लो ऐसे करके इंडिया का फ्लैग है, मान लो ऐसे. ओके, दिस इज इंडियन फ्लैग. ठीक है, इट इज होइस्टेड ऑन 15th अगस्त में भी, और ये हाइट h है मान लो, और ये फ्लैग की हाइट x है. ओके, ऐसा हो सकता है. And like you are standing over here, और you have got the device also, है ना, तो वही है, उस डिवाइस से मेजर अगर आप करते हो, ये आपकी डिवाइस है. ठीक है, वही एंगल है, मान लो ये 30 है ना, और एक दूसरा एंगल ऐसे निकालते हो आप, तो ये पूरा एंगल जो आ रहा है अभी नया, ये 45 है. ओके, गेटिंग इट? तो वही अगर इसमें मान लो बेस कितना है, बेस तो सेम ही है भाई. ओके, हाइट h, तो एक केस में अगर 1030 है मान लो, it is 1030, so 1030 is equal to perpendicular, which is h, divide by base b. ये scenario आ गया. And what is another one? Tan of 45 is equal to height of h plus x divided by h plus x divided by base. Okay, now if you know the value of tan 30, and suppose you are knowing either height or b, whatever, suppose you know the height, then you can easily find out the b can be easily found out, and you can put that value into the second equation, and into the second equation h is already known. Okay, b you have like found out in the terms of h, you are putting it over there, and tan 45 you already know, so you can find out the x. For example, tan 45 is equal to 1, getting it, h plus x divided by b, so h plus x divided by b equal to 1, so h plus x is equal to b. Okay, so x is equal to b minus h, ये आ गया. Okay, in this particular case. And how you can find out the b देख लो अब आप, है ना. b is equal to h by tan 30, b is equal to h by tan 30, ये हो गया. Okay, now if you put it like into this above equation, it will come out to be x equal to b is equal to h by tan 30 minus h, and h you already know, getting it. Getting it or not? ये देखो, ठीक है. Next page you can see that x is equal to h, common you have taken 1 by root 3, 1 by tan 30 minus 1, minus है, हाँ minus 1. Okay, so h is equal to known, suppose height was given, h is equal to known, you can find the flag, you can find the height of the flag, getting it. Height of the flag. Okay, suppose there is a scenario, are you getting the feel of it? This is how you can calculate these questions. Okay, these are the applications. Have you heard of a scenario जहाँ पे underwater वो करी जाती है, not exactly trigonometry, but जैसे कोई भी, suppose underwater in the sense, suppose this is like sea. Okay, sea is there and this is a big ship. This is a big ship is there. Okay, this is an engineering ship, you have got a unit engineering cell also inside, and this is like bottom, suppose bottom of the sea, bottom of the sea. अभी यहाँ से they send some suppose laser, some kind of, okay, or some kind of ultrasonic wave maybe. Okay, they send it here and you know the speed of them, and they again come back to the same and they capture that, getting it. Speed you know, waves speed कितनी हो गई, speed is equal to distance by time, ये होती है मीटर पर सेकेंड. Okay, so time, when you note the time, when you're throwing that ray and when it is going, when it is coming again. Okay, the reflection of it. So you're measuring the time. So what is the distance? What would be the distance? Distance would be, suppose this whole distance is h. Whole distance is h. So what will be the distance? 2h. Okay. And time, which you have already measured. Speed you already know. Speed. Getting it? Speed is equal to 2h by t. So time you have measured, 2h, h you want to find out. And speed you know. क्योंकि जो भी waves की speed कितनी है water के अंदर वो आपको पता है. So how you can find that out? So this is equal to 2h is equal to speed into time. Speed into t. Getting it? And h is equal to speed into t. Speed into t divided by 2. ठीक है? And suppose the ship has moved. ऐसे निकल के आ रही है ship, ऐसे आगे आ रही है. Okay? So this h has like, अभी ये तो pit थी, तो यहाँ पे you have calculated it, है ना? पता चल गया आपको. ठीक है? You have measured it. And this is like from some distance from the shore. So you can know that, okay, the underwater things are very down. Okay? Some trench is there or something like that. And if you are going over here little forward, then if you measure that h distance will change. Okay, then also you're sending those waves and they are getting reflected. Now the distance that they are covering is 2h or h1 or h2, whatever, because the distance would be different, divided by time you are measuring. Okay, speed you know, so that you can find out the heights of the trenches, underwater trenches, in this way. This could be one scenario. Getting it? Okay, ये एक चीज है. Suppose there is a नया सिनेरियो है, इसे सोचो. ओके, एक जा रही है सपोज किसी रोड्स पे, और वहाँ पे रोड्स में कुछ पिट्स हैं. तो यहाँ पे एक हमारे पास डिवाइस लगी हुई है कि देयर इज अ डिवाइस एट द bottom of the car body. Okay, there is some kind of a sensor is there, और वो भी इसी तरह से as the car moves. ठीक है, suppose there is some pit hole, तो वो इसी तरह से कैलकुलेट कर लेता है. Okay, so at the end of it, it is collecting the data, and what they are seeing, if the road is very flat, okay, generally the data is coming out to be uniform. And if the data is not coming out to uniform, suppose generally most of the time the road is uniform, okay, the distance that is that device is measuring is coming out to be, suppose कितना लेना चाहिए, suppose 50 one half a meter, suppose. Okay, distance half meter, 0.5 meter आ रहा है distance, 0.5 meter. मीटर आ रहा है. ओके, एंड सपोज एट सम प्लेसेस, है ना, the data that you're collecting and the distance is coming out to be maybe 0.7 meters, something of that sort. ठीक है, so if you draw a curve, okay, there could be nice analysis engine. if you are drawing the curve, तो वो इस तरीके से आ रही है, कमिंग आउट टू बी इतने, है ना, और एकदम से उसमें स्पाइक है, फिर इट्स कमिंग आउट टू बी, फिर एकदम स्पाइक है, मान लो ऐसे. ओके, सो यू कैन इजीली नो कि देयर वाज समथिंग ओवर देयर. एंड एट द टाइम ऑफ spike, if you are sending the signal in the cloud, you can exactly, है ना, trace out few things. Definitely you will need some other support of some framework, but this you can see that at least the road condition is like that. So if several cars are going on that road, okay, and if they have got some kind of this thing, so they will be drawing some graph, and that graph is like, suppose uh, we are sending that graph somewhere, okay, so you can easily see, okay, there is some disturbance, there is some pit hole somewhere, okay, so you can easily like alert the municipality or the road department, okay, some anomaly is there, it is coming in the data, and previously the data used to come in the very smooth, okay, smooth data कैसा होगा, वो सीधा ऐसा हो जाएगा smooth, okay, that means there are no pit holes on the road, but in this case there are some data is coming like this, okay, so that means there are two holes, maybe due to the rain, maybe due to the bad condition, maybe due to some other thing that has happened on the road, they have like occurred, okay, so immediately signal can be sent. So these are like next kind of futuristic things. So here also, but these are like trigonometry is not used, it is plain simple what this thing we are seeing, okay. So this is how you can think of many scenarios wherever some angle is formed and you do not want to measure the height directly, or that is not possible for you because that the building is very large. You can have some kind of a laser guided device, okay, and you can use the trigonometry over there. Some person can go and can find out the height, okay. Similarly, in other fashions, you can use the applications, could be there could be a number of applications, but it is up to you to how use them or how to like advance them, how to evolve those devices also, okay, but this is there, getting it, okay. Okay, so with this let us close this lecture. See you again tomorrow. Okay, we'll start with the next chapter, circles. Let us see. Okay, I'm closing the
Thank you, sir.
thank you, take care.